Hello and welcome to today's lesson on the truth tables for the conditional and the biconditional. So the truth tables for the conditional and the biconditional. The conditional. If the conditional is the if-then statement. In the statement, if P then Q, P is called the hypothesis and Q is called the conclusion. Now we are learning the logical definitions for connectives, much in the same way that we learn multiplication by memorizing the multiplication table. The conditional also has a definition or a rule that we must learn. In math, you can learn the multiplication table and apply it without having to know what multiplication actually means. The same goes for the rules of logic. You can learn the rules and apply them without actually understanding what the rules mean. The meaning to the rule for implication is this: if the hypothesis is true, then the conclusion must be true. If the hypothesis is false and if the hypothesis is true and the conclusion is false, then the conditional is false. If the hypothesis is false, then the conclusion can either be true or false. So let's consider the following statements. P is Bob gets an A on the final exam. Q is Bob gets an A, grade of A, for the course. So the statement, if Bob gets an A on the final exam, then Bob gets a grade of A for the course. So that's the if-then statement we're going to take a look at. Let's assume that Mr. Moore has a policy like this in his class. If you get an A on the final, then you will get an A for the course. Think about this as a promise that Mr. Moore has made to his student Bob. If Mr. Moore breaks his promise, then the statement is false. Otherwise, the statement is true. So, if P is true, so if Bob gets an A on the final exam, if that is a true statement, and Q is true, Bob gets a grade of A for the course, then the statement is true. If P is true, if Bob gets an A on the final exam, if that part is true, and Q is false, Bob does not get a grade of A for the course, then Mr. Moore has broken his promise, and the statement is false. If P is false, Bob does not get an A on the final exam, and Q is true, Bob gets a grade of A for the course, then the student could have earned the grade of A from other work in the course. So Mr. Moore has not broken his promise about what he does on the final exam, and the statement is true. And then finally, if P is false, in other words, Bob did not get his A on the final exam, and Q is false, Bob did not get an A in the course, then the student did not earn an A from either the final or the other work in the course, so Mr. Moore has not broken his promise. The statement is still true. The truth table for our conditional looks like this. So here's our input values for P and Q, and here is our truth values for if P, then Q. Notice the only time the conditional is false is when the statement P is true and the statement Q is false. Or as I like to think about it, a true on the left side points towards a false on the right side. When a true points to a false, then your conditional is false. All other places, it's true. Alright, so what is the inverse of a conditional? If we have a conditional, if P, then Q, its inverse is if not P, then not Q. So here's an example. If we have the statement, if it is raining, then there are clouds in the sky. The inverse of that statement is, if it is not raining, then there are not clouds in the sky. So we've negated both of the components. So let's take look at the example of the truth values. We're going to compare the truth values for our conditional to its inverse. So the truth table for the conditional is the following. So that's going to be true, false, true, true in that final column. Now let's build the truth table for the inverse. So taking our input values for P and Q, we want to negate our P column and negate our Q column. So when P is true, negate that, it becomes a false. When P is true, negate that, it becomes a false. When P is false, negating that, it becomes a true. When P is false, negating that, it becomes a true. Doing the same thing for Q. When Q is true, negating that, it becomes a false. When Q is false, negating that, it becomes a true. When Q is true, negating that, it becomes a false. And when Q is false, negating that, it becomes a true. So now we're going to take the result of those two statements, the not P column and the not Q column, and we're going to construct our conditional with those two columns. So my not P column is on the left and my not Q column is on the right. So our conditional, our arrow statement, the way that works is anytime we have a true on the left side pointing towards a false on the right side, that's going to give us a false. And it's going to be true everywhere else. So not P is F, so false pointing towards false, that gives me a true. False pointing towards a true, that gives me a true. Here we have true pointing towards false. So true pointing towards false, that gives me a false. And then true pointing towards true gives me a true. So these are the truth values for if not P, then not Q. So the truth values for the inverse, true, true, false, true, that's different from the truth values of the original conditional, which was true, false, true, true. So that means the inverse and the conditional are not equivalent to each other. So let's take a look at the converse of the conditional. So the converse, if we have if P, then Q, its converse, that should be the word converse, if Q, then P. So when we take a look at the converse, again, here's an example of the converse. If it is raining, then there are clouds in the sky. Its converse is going to be if there are clouds in the sky, then it is raining. So let's take a look at the truth values of the conditional and its converse. So here's the truth values for the original conditional, if P then Q. So it gives me true, false, true, true. Now let's build the truth table for the converse. Now in order to calculate this arrow statement, we really need to have the correct column on the left and the correct column on the right. So for the converse, we need Q on the left and we need P on the right. So we're going to take my Q column, put that on the left, true, false, that's my Q column, and then take my P column and put it on the right here, true, true, false, false. And now we're going to construct our conditional on these two columns. So true pointing towards a true gives me true. False pointing towards true is true. True pointing towards false. That's the only time your conditional is false, is when you have a true on the left side pointing towards a false on the right side. And then false pointing towards false is a true. So comparing these truth values, true, true, false, true, to the truth values of our conditional, which is true, false, true, true, those are not exactly the same, so the conditional and the converse are not equivalent. Alright, let's take a look at something called the contrapositive. Alright, so if we have the conditional, if P, then Q. Its contrapositive is, if not Q, then not P. So if we have the statement, if it is raining, then there are clouds in the sky. The contrapositive, that should be the word contrapositive, would be if there are not clouds in the sky, then it is not raining, and that should be not raining. So let's compare the conditional to its contrapositive, and that should be contrapositive here. So here's my original conditional. So if P then Q, that gives me true, false, true, true. So let's build our truth table for the contrapositive. So first thing, we need to negate our Q column, and we need to negate our P column. And we need to have our not Q on the left and our not P on the right. So negating my Q column, negating a true, that gives me a false. Negating a false, that gives me a true. Negating a true, that gives me a false. Negating a false, that gives me a true. Negating my P column, negating a true, that gives me a false. Negating a true, that gives me a false. Negating a false, that gives me a true. Negating a false, that gives me a true. So now I'm going to have to take these two columns, the not Q column and the not P column, and I have to apply the rule for the conditional. So the only time the conditional is true is whenever the only time the conditional is false is when I have a true on the left side and a false on the right side. So false pointing towards false is true. True pointing towards false, that gives me a false. False pointing towards true is true. True pointing towards true is true. And notice this set of values, true, false, true, true, that matches up with the values of our original conditional. True, false, true, true. So the conditional and the contrapositive are equivalent to each other. Let's take a look at the biconditional. The biconditional is our if and only if statement. P, if and only if, Q. The biconditional is true if the truth values of P and Q are the same. And the biconditional is false if the truth values of P and Q are different. So if P and Q are both true, the biconditional is true. If P and Q are both false, again, if the values of P and Q match up, the biconditional is true. If P and Q have different values, then their result is false. So, if the values of P and Q are the same, the biconditional is true. If the values are different, then the biconditional is false. All right, let's take a look at the order of precedence. If you have two or more logic symbols occurring in a logic statement, and there are no parentheses to determine which operation to do first, then we're going to follow the list below in order. So we're going to do all of our negations first. Then we do all of our and statements from left to right. Then we do all of our or statements from left to right. We then do our if-then statements from left to right. And then we do our if and only if statements from left to right. So if you don't have parentheses, this is the order in which you're going to apply your logic symbols. All right. Next thing is something called the if-then-else statements that you see in computers. In computer programs such as Excel, the if-then-else statement can be used to make decisions and calculations. They will have a format that looks like this. You'll have some calculations before the if-then-else statement. Then you're going to have the word if followed by some logical expression. And you're going to have to calculate the value of that logical expression based off of the calculations that came previously. And this result in here is going to calculate to either a result of true or a result of false. If this thing inside, if this logical expression on the if statement, if that calculates to true, then you do the directions inside the in portion. So you'll see it then. These are the calculations that are done if the logical expression in the if statement is true. If the stuff with the if statement is false, then you do the else part of the problem. So after the else, these are the calculations done if the result of the logical expression is false. So Thank you for watching this video, and I will see you next time.